Hi, my name is Sadie, and I'm a history major from the class of 2019. We're going to do Chapter 2.4, Skill Builder Problem Number 3, Parts A through C. But before we get started, first we're going to cover the concepts covered in the question. So I'm going to go over what an empirical formula means and also what the mass percent of oxygen means. To do that, I'm going to use a couple of examples. I'm going to start with finding the empirical formula. So we're going to go empirical formula and what this means. I'm going to use an example C2H4O2. This is a molecule called glycolaldehyde, and that's not important, but I'll include that right here. This part is important right here. This is a molecular formula, and this is what we're going to use to find the empirical formula. And all the empirical formula is it's the ratio of atoms inside a molecule. So here of hydrogen atoms to carbon atoms to oxygen atoms. So to find the ratio, we divide each of these numbers, the 2, the 4, and the 2, by the lowest common denominator, the number that each of them can be divided by. Here that is 2, so I'm going to divide each of these by 2, and I get a new formula of CH2O. And this right here is my empirical formula. So let's look at this. We've got an empirical formula that shows that for every 2 hydrogen atoms, you have 1 carbon atom and 1 oxygen atom. And you can see that up here too. That doesn't change in the molecular formula. It's just a reduced formula. Okay, so that's empirical formula. Next, we're going to look at what the mass percent of oxygen means. I'm going to use a new example for that. I'm going to use H2O, pretty classic molecule. Just looking at this right off the bat for mass percent oxygen. Looking at this right off the bat, you might look at it and say, well, there's 1/3 of the molecule that consists of oxygen atoms because there's 2 H's and 1 O. But you have to take size into account. So you have to remember that an oxygen atom, so say this is an oxygen atom, is much bigger than a hydrogen atom. So if you have a molecule where all of these are bonded together, you can see that oxygen is going to take up a much bigger mass. But let's figure this out with math. To find the mass percent oxygen, we're going to go through a ratio of mass of oxygen over the total mass of the molecule. And we're going to multiply that by 100 to get our percent. The mass of oxygen can be found using the periodic table. You have the mass values up there for each atom. So for oxygen, you have 1 oxygen atom, and that is 16 AMU. So that's our mass oxygen. But for the total mass of the molecule, you have 1 oxygen atom that's 16 AMU plus 2 hydrogen atoms, each at 1.01 AMU. And I don't really need to include the A in there. Multiply it by 100 to get the percent. You get 16 over 18 times 100, and that comes out to 88.8%. And voila, we have our mass percent oxygen for water. Okay, so now to get started with the actual problems, parts A through C. Part A is is a molecule called H2O2. So this is a molecular formula that we're given. The first thing we need to do is find the empirical formula. Empirical formula. So right away you can tell that the lowest common denominator for these number of values right here is 2. So if you divide each of these by 2, you get H2 over 2, O2 over 2. That gives you HO. So that is your empirical formula. It shows you that for every 1 hydrogen atom you have 1 oxygen atom. gonna go ahead and box that. So for the mass percent of oxygen, okay, so now what we need to do is look at how much of what mass of the molecule consists of oxygen. So here we go, mass of oxygen over total mass times 100. Okay, so this time we have 2 oxygen atoms, so it's 2 atoms times 16 AMU over the total of 2 hydrogen atoms at 1 AMU plus 2 oxygen atoms at 16 AMU times 100. That's going to give you 32 over 34, and that's 94.1% right here. So that is our... Okay, and so that is our mass percent of oxygen. Okay, so that is the end of part A. So let's go ahead and move on to part B. And that is a new molecule. It's C6H12O6. So again, they give us the molecular formula. So what we can do is go ahead and find the empirical formula, just right off the bat. If you look at this molecule, you can tell that the lowest common denominator of these numbers right here is 6. Each of them can be divided by 6. So we're going to rewrite this as C, 6 over 6, H, 12 divided by 6, and O divided by 6. And that gives us CH2O. This right here is our empirical formula. It shows us that for every 1 carbon atom we have 2 hydrogen atoms and 1 oxygen atom. So that is our empirical formula. Now to move on to mass percent oxygen. So again, we're going to find the mass of oxygen. Oxygen, it looks like a 0, and then over the total mass. We're going to multiply by 100 to get the percent. This comes out to 6 oxygen atoms times 16 AMU over 6 oxygen atoms times 16 plus 6 carbon atoms times 12 AMU for the mass of carbon plus 12 hydrogen atoms times 1.01 AMU. Multiply by 100. We come to the conclusion that this is 53.3% oxygen, and that is our mass percent of oxygen. Okay, so now we're done with part B. Move on to part C. This is our last part. It's written as HC2H3O2. Oh, just O. C2, 3, yeah, just like that. So this can be rewritten because we have this H out in front, and so it kind of throws us off a little bit, throws a wrench into the problem. But we can rewrite this formula to give us C2H4O2, and now it looks just like the parts A and B. We can go ahead and find the empirical formula. Empirical formula. So if you find the ratio, it's going to be, we're going to divide each of these by 2, and that gives us CH2O. This is the same as in part B. We have the same ratio, C to H to O. Pretty easy. Now, for the mass percent oxygen, we're going to have the mass of O over total mass, which is 2 oxygen atoms times 16 AMU over 4 hydrogen atoms times 1 AMU plus 2 carbon atoms times 12 AMU plus 2 oxygen atoms times 16 AMU. this comes out to, here, I'm going to move it up. This comes out to 53.3% after you multiply it by 100. Which is, again, the same as in Part B because they have the same ratio. And that is it. That is the end of the video. I hope you understand what an empirical formula is and also what the mass percent of oxygen is. Thank you for watching.